To establish a safe procedure for working on electrical equipment when utility lockouts are not permitted, this procedure applies to all personnel performing electrical maintenance or repair on utility power equipment. Pre-job planning should include contacting the utility company and obtaining written authorization for the work to be performed. Identify all electrical equipment that will be affected by the shutdown and determine if lockouts are permitted. If lockouts are prohibited, establish alternative safety measures, such as grounding devices. For equipment without a main breaker, firstly, verify that the utility power has been de-energized at the source. Secondly, ground the equipment using a properly rated grounding device. Thirdly, test the grounding device with a voltage tester to ensure it is effective. Fourthly, follow all applicable safety protocols for working on de-energized electrical equipment. For pole-mounted cutouts, firstly, visually inspect the cutout for any damage or indicators of potential power. Secondly, use a long-handled insulated hook stick to open the cutout switch blades. Thirdly, verify that the blades are open and that there is no power coming into the cutout. Fourthly, ground the cutout with a properly rated grounding device. Fifthly, test the grounding device with a voltage tester to ensure it is effective. Post-job completion should include firstly, removing the grounding device and close the cutout switch blades if applicable. Secondly, recontacting the utility company to restore power to the equipment. Thirdly, documenting the work performed, including any alternative safety measures used. Additional precautions should include firstly, ensuring that all personnel involved in the work are trained and qualified to work on electrical equipment. Secondly, use proper personal protective equipment, including insulated gloves, face shields, and flame-resistant clothing. Thirdly, post clear signage around the work area indicating that the equipment is de-energized and being worked on. Fourthly, monitor the work area continuously for any potential hazards. This procedure is a general guideline and may need to be modified to suit specific job requirements and equipment configurations. Always refer to manufacturer's instructions, industry standards, and local regulations for additional guidance. When performing lockout tagout procedures on electrical equipment where the utility company does not allow you to place lockout devices on their equipment, it is important to follow a written procedure that ensures the safety of all personnel involved. This procedure should include several key steps. Firstly, pre-job planning is essential. Contact the utility company to inform them of the planned work and obtain their written authorization. This communication is crucial to ensure coordination and understanding of the work to be performed. Secondly, identify all electrical equipment that will be affected by the shutdown. Determine whether lockouts are permitted on each piece of equipment. If lockouts are prohibited by the utility company, it is necessary to establish alternative safety measures, such as the use of grounding devices. Thirdly, for equipment without a main breaker, the procedure must outline specific steps to ensure de-energization and grounding. Begin by verifying that the utility power has been de-energized at the source. This verification should be done using appropriate testing equipment to confirm the absence of voltage. Next, ground the equipment using a properly rated grounding device. The grounding device should be connected in a manner that provides a secure and reliable path to ground. After grounding, test the grounding device with a voltage tester to ensure it is effective in providing a safe path for any potential electrical current. Following these steps, adhere to all applicable safety protocols for working on de-energized electrical equipment. Fourthly, for pole-mounted cutouts, a similar procedure should be followed, with additional considerations for the specific equipment. Start by visually inspecting the cutout for any signs of damage or indicators of potential power. This inspection can help identify any immediate hazards or issues with the equipment. Use a long-handled insulated hook stick to open the cutout switch blades. This tool allows for safe operation from a distance, minimizing the risk of electrical contact. Verify that the blades are fully open and that there is no power coming into the cutout. Again, use appropriate testing equipment to confirm the absence of voltage. Ground the cutout with a properly rated grounding device, ensuring a secure and reliable connection to ground. Test the grounding device with a voltage tester to ensure it is effectively providing a safe path for any potential electrical current. Fifthly, post-job completion is an important part of the overall procedure. After the work is completed, remove the grounding device and close the cutout switch blades, if applicable. Recontact the utility company to inform them that the work is finished and to restore power to the equipment. Document the work performed, including any alternative safety measures used. This documentation provides a record of the work and can be valuable for future reference. Additional precautions should always be taken to enhance safety. Ensure that all personnel involved in the work are properly trained and qualified to work on electrical equipment. Training should cover the specific procedures and equipment being used, as well as general electrical safety practices. Use proper personal protective equipment, including insulated gloves, face shields, and flame-resistant clothing. PPE provides a critical layer of protection against electrical hazards. Post clear signage around the work area indicating that the equipment is de-energized and being worked on. Signage helps to alert others to the potential hazards and prevent accidental energization of the equipment. Monitor the work area continuously for any potential hazards. This monitoring can help identify and address any unforeseen issues that may arise during the work. It is important to recognize that this procedure is a general guideline and may need to be modified to suit specific job requirements and equipment configurations. Always refer to manufacturer's instructions, industry standards, and local regulations for additional guidance. In summary, when lockout tagout procedures are performed on utility power equipment without the ability to use traditional lockouts, the focus should be on thorough pre-job planning, the use of grounding devices, and strict adherence to safety protocols. Proper training, PPE, and continuous monitoring are essential for ensuring the safety of all personnel involved. Grounding devices play a critical role in protecting workers from electrical hazards when traditional lockout methods are not feasible. Branding provides a low impedance path for fault current to flow back to the source, which helps to quickly trip protective devices such as circuit breakers or fuses. This rapid clearing of the fault minimizes the duration of the electrical exposure and reduces the risk of injury or equipment damage. The effectiveness of a grounding system depends on several factors, including the quality of the grounding electrode, the conductivity of the grounding conductors, and the proper installation and maintenance of the system. Grounding electrodes are typically made of copper or galvanized steel and are buried in the earth to provide a direct connection to ground. The size and type of grounding electrode required will depend on the specific electrical system and local regulations. Grounding conductors are used to connect the electrical equipment to the grounding electrode. These conductors must be of sufficient size to safely carry the maximum fault current that could occur. The National Electrical Code, or NEC, provides detailed requirements for the sizing and installation of grounding conductors. Proper installation and maintenance of the grounding system are essential for ensuring its continued effectiveness. Grounding connections should be inspected regularly to ensure they are tight and free from corrosion. Grounding conductors should be protected from physical damage and should be replaced if they become damaged or corroded. In addition to grounding, other safety measures should be implemented to protect workers from electrical hazards. These measures may include the use of insulated tools, rubber gloves, and other personal protective equipment. Workers should be trained to recognize and avoid electrical hazards, and they should be familiar with the proper procedures for working on electrical equipment. The National Fire Protection Association, or NFPA, Standard 70D provides guidance on electrical safety in the workplace. This standard covers a wide range of topics, including hazard assessment, personal protective equipment, and safe work practices. Following the recommendations in NFPA 70E can help to reduce the risk of electrical injuries and fatalities. When working on electrical equipment, it is important to always assume that the equipment is energized until it has been positively de-energized and tested. This assumption will help to ensure that workers take the necessary precautions to protect themselves from electrical hazards. In addition to the steps outlined above, there are several other factors to consider when developing a lockout tagout procedure for utility power equipment. These factors include the specific equipment being worked on, the location of the equipment, and the potential hazards associated with the work. The lockout tagout procedure should be tailored to the specific circumstances of each job. The procedure should be reviewed and updated regularly to ensure it remains effective and up to date with current regulations and best practices. All workers who are involved in the lockout tagout procedure should be properly trained on the procedure and their responsibilities. Training should be provided on a regular basis to ensure that workers remain proficient in the procedure. The lockout tagout procedure should be documented and readily available to all workers who are involved in the procedure. Documentation can help to ensure that the procedure is followed consistently and that all workers are aware of their responsibilities. A lockout tagout program should be developed and implemented to ensure that the lockout tagout procedure is followed consistently. The program should include provisions for training, documentation, and auditing. The lockout tagout procedure should be audited regularly to ensure that it is being followed correctly. Audits can help to identify any weaknesses in the procedure and to ensure that workers are following the procedure correctly. By following these steps, you can help to ensure that workers are protected from electrical hazards when working on utility power equipment. Consider arc flash hazards. An arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical system. Arc flashes can cause serious burns, blindness, and even death. To protect workers from arc flash hazards, it is important to conduct an arc flash hazard assessment before starting any work on electrical equipment. The arc flash hazard assessment will determine the potential arc flash hazard and the appropriate personal protective equipment that is required. Personal protective equipment, or PPE, for arc flash protection may include flame-resistant clothing, a face shield, and insulated gloves. The type of PPE required will depend on the potential arc flash hazard. It is important to use the correct PPE and to ensure that it is in good condition. Workers should be trained on how to properly use and maintain their PPE. Safe work practices should be followed to minimize the risk of an arc flash. These practices may include energizing the equipment before starting work, using insulated tools, and maintaining a safe distance from energized equipment. A lockout tagout procedure should be followed to ensure that the equipment is de-energized before starting work. The lockout tagout procedure should be documented and readily available to all workers who are involved in the procedure. An arc flash hazard assessment should be conducted before starting any work on electrical equipment. The arc flash hazard assessment will determine the potential arc flash hazard and the appropriate personal protective equipment that is required. Personal protective equipment for arc flash protection may include flame-resistant clothing, a face shield, and insulated gloves. The type of PPE required will depend on the potential arc flash hazard. It is important to use the correct PPE and to ensure that it is in good condition. Workers should be trained on how to properly use and maintain their PPE. Safe work practices should be followed to minimize the risk of an arc flash. These practices may include energizing the equipment before starting work, using insulated tools, and maintaining a safe distance from energized equipment. A lockout tagout procedure should be followed to ensure that the equipment is de-energized before starting work. The lockout tagout procedure should be documented and readily available to all workers who are involved in the procedure. Electrical safety is a critical aspect of working with utility power, and a comprehensive approach that includes proper lockout tagout procedures, grounding techniques, arc flash protection, and safe work practices is essential for ensuring the safety of all personnel involved.